My name is June Heider. I work for a company, RealEyes Media, and this session is Video Machine Learning Demystified. Just some background information, then we'll get started. I'm the CTO at RealEyes Media. I'm also a machine learning enthusiast, keyword enthusiast, and you'll see why. RealEyes Media, we've built cross-platform video players seen by millions. Super Bowl video players, Olympics. We build ECDNs, live streaming infrastructure. We love building solutions to manage live and VOD content. Partner with cool industry leaders. And I wrote a white paper on video indexer for Microsoft. That was kind of fun. Anyway, disclaimer. I am definitely a long-time technologist. I've been in the industry for quite some time. I don't attest to be a machine learning expert just because I pip installed TensorFlow. But, you know, I can be an enthusiast. How many of you are machine learning engineers? How many of you had played with some kind of video machine learning at some point? A couple of you. How many have trained your own video machine learning model? None of you. Okay. So this is going to be really fun. By the way, all the opinions and all this information is based on my enthusiasm and experience of learning and playing around with this stuff over the last several years. I know there's plenty of brilliant people out there that can dive deep into the weeds, but I kind of want to show you what these things can do. And then also, there's a really cool community. It's called Video Dev Slack. And feel free to grab a card, and we can invite you at some point. They'll be right here. Feel free and come by later. So what we're going to talk about today is things to consider before you actually train a model. And then from there, we'll talk about some concepts when it comes to machine learning. And then if you decide that you do want to train a model, we'll talk about how to create your training data and how to train up your model. And finally, we'll wrap it up. So before you train, that's a really critical thing to keep in mind. Because I personally believe that you can keep things simple. You don't have to dive into the weeds unless there's an absolute reason to. There's a lot of vendors out there, many vendors out there, and each one has their own specialty. One I found just recently is DeepQuest AI. They look pretty interesting. You can do on-prem, you can do in the cloud, and it's free to use from what I can tell. And then if the exhibit hall is still open, there's a vendor called Rev. And if your use case has to do with audio, they do some transcription. And they can do live transcription as well. We were going to try and set up a demo, but it would have required a second screen that I don't have access to right now. But yeah, feel free and check out any of these vendors. There's many different types of video analysis out there. These are some of the most common use cases. The one that you've probably seen for a while is object detection. Hey, it's a hot dog. No, it's not a hot dog. Facial detection is definitely a very hot use case as well. And the list goes on and on. Celebrity detection, doing transcriptions, scene and shot detection for post-production, logo and brand detection for making sure people aren't using your Ferrari logo in an inappropriate way, and sentiment analysis to know if I'm neutral right now or if I'm negative or positive. There's even more kinds of video analysis out there as well. Non-transcription audio analysis. Maybe all you want to do is figure out which videos you have that have some background music in them, or which videos you have that may have been taken in the jungle. They do have vendors out there that can tell you if there's nature sounds or music or guitars playing. Maybe you want to find out where a video was shot. Eiffel Tower's in the background, so knowing landmark detection. Or maybe you want to post to social media and having an AI service that can pull highlight clips out of a 2-hour sports game, that'd be kind of cool. And then you don't have to do it. So there's more use cases that come out every day as the community continues to play with these machine learning services and build and inspire each other. Well, sometimes these services don't quite fit the mold, but they're close. So some of these vendors do offer the ability to do some slight customization. And generally, we're talking face galleries. So AWS, Veloso, and Video Indexer all have the ability to create your own face galleries so that that information can be used while the machine learning is parsing through and indexing your video. And then a number of providers also give you the ability to create your own dictionaries. So when somebody is talking, you know, there may be a specific way to spell somebody's name that's non-standard. You can provide a dictionary. Or if there's a lot of, you know, jargon that you have that is very non-standard, like we wouldn't be talking about it at lunch because it's legal or it's technical or medical, you can create dictionaries. The one thing you want to do, keep in mind in regard to transcription is often if you have multiple speakers or if there's a lot of background noise, it makes it very difficult for these machine learning services to get a super accurate transcription. So we're just going to do a really quick demo and see kind of what some of these services offer. So let me get out of full screen. So first off, I was talking about Video Indexer. So Video Indexer is a service that I've been playing around with for quite some time, wrote a white paper, those kinds of things. The concept is if you have a library, you can use their API if you have thousands of videos. Or as a user, you just want to play around. They do give you the ability to use their user interface to upload videos. So I go in here and I browse for a file. I find a video file. Let's do in the wild. I like ramen. And then at that point, you set some, you know, parameters in here for the upload. And it's kind of hard to see, so I'll kind of expand it a little bit. Oftentimes, they need kind of a language hint for the transcription. So you may need to tell it, hey, by the way, this is Russian, this is not English, et cetera, et cetera. And then you click upload. I'm not actually going to upload it right now. Actually, why not? I'm going to upload it right now. So it's going to upload the video, and then at that point, it's going to switch over to the list view. And you can see in the background that this video is currently being indexed. So the machine learning service is going through and it's saying, hey, who's in this video? What objects exist in this video? What kind of sentiment do I feel? What is being said in the video so that I can create a transcript? And I'm going to show you while that's uploading. I'll show you a previous one I uploaded. Let's go with this one, bowling. So this is a video of my son. I don't know if there's going to be audio or not, but he's bowling. As you can see, we have some labels here. So this is an indoor scene. There's bowling happening, which is a sport, and there's a person in this video. And here you can actually see where the machine learning service detected that particular entity within the video. And they allow you to scroll back and forth and do all these things. It's actually even calculating what scenes exist in this video as well. And then if we look at the timeline, what was said in the video is being transcribed. And the cool thing with Video Indexer is they give you the ability to download various caption formats, whether it's a SRT or VTT or TTML. If it's a long video with a lot of dialogue, you can actually turn auto scroll on. So it will actually kind of scroll through as the audio is being spoken. And then you have the ability to translate. So maybe I want a transcript in Bulgarian instead. So there we go. So that's pretty cool. And that's all automated. All I did was upload a video, and this machine learning service went in and, you know, figured out what was in it. Let's go back. Let's go to this one maybe. So this one has a little bit more insights that it generated from indexing this video. One of them being, this isn't quite the right person here. It's not Leona, it's Leonard Nimoy. So they give you the ability to do some slight customizations. In this case, hey, I want to populate a face gallery. So Leonard, does that look right? All right, and then I'm going to say cool. We also have the ability to come in here and modify the transcript as well. Once we're done editing, we can go under our settings and look at the customizations that they expose. So for instance, we have this content model customization in here. And I even added my son in here. So that future videos that are indexed may potentially be able to detect him in the videos. We also have the ability to create our dictionaries in different languages. We could upload a file that has our jargon in it, or when I go in there and edit the transcript, it allows me to basically make these overrides in there. So that's kind of cool. They have brands, but the thing about Video Indexer is they don't actually detect logos yet. What they do detect are things like OCR. So if there's a brand mentioned on the screen in text, they can pull that, they can extract that out. Or if they hear somebody talking about Twitter or Facebook or whatever, they can notice that there's brands in there. So if you have brands that you want to include or you want to exclude, you can actually come in here and you can say, hey, by the way, here's the brands I want to know about, here's the brands I don't want to know about, and I don't want any brand suggestions by Bing. So slight customizations. And it's still indexing, so we're going to move on. So Veloso is another offering, and this is a company based in Finland, and I've been playing with their tool for a while. It's a very, very exciting tool. I like it. So in Veloso, we have the same kind of concept where we can upload a video, or if we're a developer, we can use their API to say, hey, please upload and index this video. If I drag something in here, and this time let's go at this one here, Pierce Brosnan, it looks like 007 or something. They give you some options. So you can actually say, hey, these are the things that I care about when I index this video. Like, I just want everything. Or I can come down here and I could say, all I care about are faces. Or all I care about are faces and audio tags. So they allow you to decide what you're going to actually index. And if you notice, as you change these options, it changes the pricing because it affects how much processing they have to do on your video. But you know what? I want the full indexing on my video. And then at that point, you can give it a title. You can tell it what the language being spoken in the video is. And then you can even set like some thresholds on facial detection. Once we're happy, we'll just upload and analyze. And we do that. And while that's being processed, we can see in our list that we have, this one that's queued. It's waiting for machine learning resources to index it. We'll take a look at this one here that I already pre-processed. And we have the ability in here to see AV tags, IAB tags for taxonomy purposes, categories, faces, audio categories. So here's where we have this isn't just a transcript. There's humans in here, there's music in here, styles, mentioned, so things mentioned in the audio. Cuddlebug machine, that's what she got, that was her gift. Other visual context. The really cool thing about Veloso too is they have this kind of heat map concept. So we could see we have 2 unknown people in here. So once again, we can do like a slight customization. If I know that this is my son Kobe, I can come in here and I can select a gallery that I've pre-created, or I can just use the default. And then I can say, hey, who is this person? I can select an identity, or I can add a new one. So that's pretty cool. I'm not going to do that right now because it takes a couple minutes. Oh, shoot. Oh, yeah. Just don't save the changes and you're good. The other cool thing that they let you do, too, is sometimes if somebody has like a different angle that they're looking, or maybe they may have taken their hat off, ML might detect that as a different person. So they give you the ability to merge the people that were detected together if they're the same person. So like when I ran the Star Trek video through earlier, Spock was in there multiple times, but it was detecting him differently based on the scene. So I just went there and I kind of merged where Spock was seen. And then after that, all of those images get added to the gallery. So if I go back to training, in here I can see, oh, here's a gallery. I'm going to actually choose this one. And we can see, hey, there's Mr. Leonard Nimoy, and here's all these different angles and different environments in which ML saw his face. So that can be used in future processing jobs. So, slight customizations, things that you can do out of the box. It's keeping it simple. If this fulfills your use case, go for it. You don't need to train a model. But let's talk about that now. So first off, if you are going to be training a model, you need at least the basics. I'm not going to show a bunch of formulas up here because I personally don't understand them either. That's what I use the experts for. But you know, we have AI. AI is things like Skynet. We're not there yet. It's general artificial intelligence. They can pass the Turing test. Machine learning is a subset, and it's very simple answers to very simple questions. Hey, is that a hot dog? No. Okay, great. Machine learning uses these things called neural networks. And here's some examples that I pulled to kind of give you an idea of how they work. Right? So we have an input layer, and that's where things are coming in. Frames, videos. And then we have one or more hidden layers. And how these hidden layers operate is they kind of, in very conceptual chunks, reconstruct to predict that something exists. So for instance, think about having a 9 and having an 8. They both have a circle at the top. One of them has a line below. One of them has a circle underneath. So initially, as it's kind of going through these hidden layers, it may think, oh, it's the same thing. But then as it starts to put the picture together, it'll notice these patterns, and then, oh, there's a line, there's a circle. They're not the same thing. And finally, it will try and tell you that this may be a 9, and I'm 80% confident. So it kind of like reconstructs it back up and gives you a prediction. There's different kinds of neural networks. So a really popular one when it comes to computer vision is a convolutional neural network. That's what it looks like. I'm not going to go into huge detail on that one, but you know, it gives you an idea. We have our input layer, and then from there we go through hidden layers. Finally, we go to our output layer where ML says, you know what? I'm about 84% confident that that's a robot. Great, thank you. Then we have a neural network called the YOLO. You only look once. So it's designed differently, but the concept is the same. You have an input. It goes through all these hidden layers, and then it predicts that, hey, there might be a dog and a bike and a car in this part of the video. So what is a model? So as you're training using this neural network, you end up with this artifact that you can then apply within your business application. So there's these models that are being used by both Video Indexer and Veloso. Not just one, I'm sure there's multiple models. But these models are trained to make certain kinds of predictions. And it's the artifact that you use when you're running ML in your application. So you pick a neural net, you train it, and there's your model. We're going to use two a little bit later here, YOLO and ResNet 50. There's different kinds of learning. With Video and ML, we use supervised learning. What supervised learning is we actually give a bunch of training data to our neural net to generate that model off of. And it's a supervision kind of scenario where it's not kind of deciding based on no input whatsoever, which is unsupervised. It's using all the stuff that we've tagged as a human to make these predictions. Transfer learning's kind of interesting because you can actually take a pre-existing model and then train based off of that rather than having to start from scratch. So there's different kinds of learning. We have different types of data sets when we're training. The big one is the training data set. So I'm going to have 1 million videos of cats, and I'm going to train my model based on that. Then we have a little subset of that, which is validation, and that's used as it's iterating through the training to make sure that, hey, am I getting better? Am I getting better? Am I getting better? Cool. And then finally, a test data set where it's probably unlabeled, and you use that to see, do I want to go continue training my model, or is it good enough? Things to keep in mind when you're training is bias, especially when you're creating a training data set. For instance, if you're trying to, do things with video that include people from all over the world, you want to make sure that skin tones, genders, ages are all represented. You don't want to be too narrow in your training data set. Imagine an interaction bias. So if your training data set that represents shoes, you're training your model to be able to predict shoes. If you don't have any high heels in there, that's going to be a problem because it's not going to detect high heels ever as shoes. And then another example of bias, this is more in kind of like recommendations and stuff. If I continue to select disaster movies, eventually all the other types of movies that I might like, they may be the only ones that show up. And that wouldn't be very fun. So bias. We also have this concept of spatial versus temporal. So like with video, we have these services now where we can throw our videos up there, and they have this concept of temporal. So for instance, Veloso in compliance detection can say, hey, that's a very violent scene because this person looks like they're about to punch somebody else. That's temporal. Spatial is just, hey, I saw the hot dog at X and Y, right? And another thing to consider is on the right, where my daughter's unwrapping a package, if you think about that middle frame, you can't really tell just based on that frame that she's unwrapping versus wrapping. So that's where temporal can come into play. And think of like that sports use case where you're thinking goal, basket, et cetera, et cetera. Like having some frames on either side allows you to make that kind of temporal decision. And each one of those has kind of a different neural network that is optimized for that. So CNN, RCNN. We also have the concept of precision versus recall. So that's going to depend on your use case, which one is more important to you. In the case of precision, imagine I have a store and I have 1,000 different types of high heels, okay? If I have too many false positives, nobody's ever going to want to search in my store because it's going to pull up random things like pantaloons. I'm looking for high heel shoes, not pantaloons. So in that case, we want a very, very precise model. We also have recall. And think of recall in preventing false negatives. So in a case where we're doing facial redaction based on, the bounding box of the face, if we have too many false negatives, we're not going to redact the child in the middle. And sorry for the horrible Photoshop job, but that child in the middle's face has not been redacted, and I just failed my job. So in those cases, we'd want a high level of recall. And you'll see that here when we look at one of our training systems. And then finally, confidence. I keep mentioning I'm this % sure. And the thing with ML is it's never perfect, it's just less wrong. I like that quote. I can't remember the source, I'm sorry, but I know it's a quote, it's not my own thought. So in this case, we have a false positive, which is a bear, at 57% confidence, but then we have a true positive, which is cat, at 98.732% confidence. So that's always something to consider, because the less confident the model is, you may not want to use that data. So you always want to kind of factor that in. So there are things that we can use if we want to kind of start from scratch. Python's a programming language that a lot of data scientists use. And this demo I'm going to show you here in a second is based on Python. OpenCV has been around forever. It's the computer vision library that a lot of people use for, these kinds of indexing jobs. TensorFlow is a machine learning platform. Keras is an open source neural network library. And then Visual Studio Code is my favorite IDE ever, mostly. So let's do a demo. This demo is outstanding. I can't take credit. Olafenwa Moses, he's the one that created this blog post and built this open source library, which is very, very simple to use. So let's take a look. So I'm in my favorite IDE ever, Visual Studio Code. And what I'm going to do is I'm going to show you over here what's on the left. So I have a bunch of files, and I didn't spend a lot of time making this dynamic, allowing me to give it arguments so that I could not have to hard code everything into my Python script. So apologize for that, but I was in a rush. But we have a couple Python scripts in here. And then the other important thing to note is these .mp4 files. MP4, oh, not these MP4 files. These .h5 files. So these H5 files are pre-trained models. So these are the artifacts of this machine learning, so training. One of them was using the ResNet 50, and the other one was using the You Only Look Once neural network. So the nice thing about this library is it allows you to do very simple code to do object detection. So in my case, ImageAI is the name of the library. And for those of you that want the slides afterwards, feel free to grab my card and, or fill out the feedback form. And we'll send them out within the next couple days or week or whatnot. All right, so I'm importing ImageAI library. I need the video object detection class in there. I do some file system stuff so that I don't have to type out full paths. But the important stuff here is I'm instantiating this object detection class, and I'm letting it know that I want to use the YOLO model in this particular case. And I set the path, I load it, and then I say, you know what, I want to detect objects from this video. And I give it some arguments. Input file is this Japanese ramen.mp4. Output file is this Japanese ramen detected YOLO. I can play around with the frames that are used in detection, and then I can determine to log progress. So while I'm in here, I'm not going to detect because it actually goes frame by frame by frame by frame, and it's going to take quite some time, maybe 15 to 30 minutes usually. It's probably because my Mac is slow or something. But what I can show you is I did this on Monday. The result was this Japanese ramen video where it's actually detecting things with bounding boxes. And it's giving you the % confidence in line right there as well. So I'm kind of tracking through a little bit. It's kind of interesting. I'll let it play, because the nice thing is you can actually play the video and these bounding boxes kind of follow around where it detected. So that's kind of neat. I'll show you another one. I did one earlier of my cats, and this is using the other model, the ResNet 50 model. So all I had to do here was, you know, if I was a smarter developer, I wouldn't do this, but I commented out ResNet, and then I comment these guys so that I'm using the other model. So it makes it really interesting and fun to kind of play around with these models. And using that, I created this artifact here, which is Retina. And we can see in here, this one needs a little bit more training, a lot more training. It's not a dog. It does detect a person and handbag, and this is my favorite part right here. Where we start going up on the tree, we think it's a bird, we think it's a cat, we think it's a dog. We have different levels of confidence in here. There's even a point where it thinks this cat is a bear, which is kind of funny. So, hey, you know, I mean, for certain things, if you don't care about cats and you just care about human beings, like these models are pretty good at detecting people. But if you're trying to distinguish between your two cats, these models need a little help. This library does offer the ability to take one of these pre-existing models and do some transfer learning on top of them. I haven't gotten to that point yet, but if you get my card, I'm more than happy to let you guys know when I've played around more. So that's cool. The other cool thing is they also do this live thing. So if you read through this blog post, he actually created a video capture object, and then he's detecting objects from video using the camera. So I'm actually going to run this now. And as soon as my camera turns on, it's on. It's looking at me. I'm going to look at the audience very, very slowly. Look around the room. Ooh. All right. And then I'm going to stop so that we can move on to other cool things. I think it's Command Z. Oh, no, I just terminate. All right. So while it's doing that, it's generating another AVI file. So it's very, very, I don't know why it's so quick. It's probably, yeah, I have to figure that out. I'm just starting to play with this. So I can come in here and see that depending on where, oh, I have a tie, but it's not quite a tie, so I need a little bit more training there. Where's the rest of it? All right, we'll just look at it really fast. But you can see it's detecting different things. Anyway, so that's pretty fun. So as we could tell, what I care about is having a model that can detect my white cat and my brown cat. I can't quite get there with that. So for this, I need to prep training data. One thing about prepping training data is knowing your use case. What are you trying to do? That's always the first question to ask. What am I trying to do? And what are my KPIs? Like, you know, like for instance, transcription. Being that we are government, we need like 100% accurate transcription, otherwise wars can be started and it's not good. But if all I care about is just having a transcript for, you know, a webinar, maybe 80% is fine. You know, so think about your use case and think about like kind of what your KPIs are. The other thing is when you're training, try and kind of think about any of the videos that you're going to process with your system. You want to kind of train with similar videos. For instance, every single video I've taken of my cats is on my iPhone. So what I do is I'm using my training data from my iPhone that's actually scaled down to 1080p because a lot of these vendors, you know, don't parse 4K. But I'm trying to be consistent there. The other thing is if you had a security camera that's like old and you're trying to detect objects in that footage, you may want to have low-res quality video as your training data. And then you want to make sure it's well labeled. So your bounding boxes should be tight. You don't want to necessarily go to the first frame because we have that kind of concept of temporal. And then also, if a frame has every single label that you want to notate within your model, and everything is in there. So both my cats are in a frame. I need to put bounding boxes, otherwise I will get a false negative. You don't necessarily have to create your own training data. There's tons of data sets out there already. It depends on your use case, once again. For instance, either of these two indexes, if you go click on the link, they have hundreds of video data sets available. Two examples. If you're building an application to determine people making salads, this first data set may help you. It's a data set that captures 25 people preparing 2 mixed salads each and contains over 4 hours of annotated accelerometer and RGBD video data. Very, very specific. But hey, if you're in a salad applications, that might be the data set for you. Another one has to do with like car accidents. Almost 1,500 videos collected from YouTube with different types of car accidents. So maybe you're building some kind of app that it's for insurance actuators or whatever their names are. And then there's 20BN data sets. This one's kind of interesting. It's the something something data set. And look at how many videos are in this data set. 220,000 videos. The test set alone is almost 30,000 videos. And there's 174 different labels, putting something on a surface, turning something upside down. So yeah, there's a lot of data sets out there. So depending on your use case, you may be able to get away with not having to create your own training data. However, if you do, you need to ask some questions. Do I have the bandwidth to do this on my own? If so, what tool am I going to use? What's the setup time for this tool? How accurate is it? Do I have to pay for it? If you want to outsource, you got to think about how you're going to outsource. Think about your use case again. Can I just get like one freelancer to do my annotations over the course of 2 or 3 months? Yeah, maybe. Do I want to crowdsource it? Use a service like Mechanical Turk, where if I have like 2 cats, it's not a very tough thing to annotate as long as you give them good instructions. So that might be a cheap way to do it and get a crowdsource. But they do have specialized vendors for more complex use cases. Maybe you want to do semantic segmentation, which is rather than bounding boxes, you're actually drawing like an overlay on top of the objects. And that's used a lot in computer vision for self-driving cars. And then vendors, I've talked to a number of vendors, and they have different pricing models. Some charge on volume, others hourly. But regardless, I don't think you can start with any of these vendors unless you have at least a couple $100 to a couple $1,000, even for a small data set. And sometimes they have a yearly commitment or a monthly commitment. So consider your options and what is going to work best for you. If you do decide to do it on your own, there's a number of tools to create your own training data. A number of them. A lot of them are a little bit more geared towards images. Like the ones that you can use for video annotation are still like coming out. But image annotation tools have been around for a bit. And you could use those if you're painstakingly going through each frame and annotating them. And then here's some of the providers I mentioned earlier. So you say, hey, I have a very specialized video annotation use case. I need to create tons of training data. I have the budget. Here are a number of people that you can talk to that specialize in this versus something like Mechanical Turk, where it's just microtasks. So I'm going to show you this tool that I found recently. It's a video annotation tool from Microsoft, and it's on GitHub. And they have builds that you can download and run. I think it's in Electron. But it's called VOTT. So this is the interface right here. And I'm just starting to play around with it, so I don't know it 100% yet. But it looks cool. It looks worth checking out. So I could come in here, and I can create a new project. I give it a name. I could put a security token on there to use to encrypt sensitive data. I can tell it where my source files are, and I can tell it where to spit the annotations out to. And I can do that by adding a connection. And they have 3 different options as of now. One is the local file system, another one is Bing image search, and then you can actually use Azure Blob Storage as well. So I select my source, I select my target, and then I say, hey, frame extraction rate, so how quickly do we want to extract frames so that we can tag them? And then I can start off with some tags that I know that I want to annotate with. I created a project for my cats, Ori and Eero. So I created a source for input and a source for output. And you'll notice that I have 2 tags in here right now. So as I'm annotating, the concept is I'm going to come in here and I'm going to draw a bounding box. So do that. And then once I do, I can say Ori. Oops. Didn't work. Hold on. Worked earlier. And this is an alpha version. Let's draw a box. And you want a kind of a tight bounding box there. Ori. There we go. So the concept is you have to come in here and you have to draw boxes around everything you care about. It's very, very painstaking and painful. But that's what you have to do. So that is VOT. So let's talk about training our model. So this is the general process at a high level. You collect a lot of good training data, a lot, thousands, millions maybe. Then you train your model, and you test your results. And then guess what? You keep doing that over and over again until you're happy with the level of prediction that your model is going to provide for your use case. Once you're happy, then you can deploy and utilize. That said, I'm going to go through here and show you something that you can do where you don't have to deal with TensorFlow. You don't have to deal with understanding Python code. You don't have to be like a machine learning expert. You can start playing around. And I highly recommend playing around with it right now because it's still in beta. So sign up for a free Google Cloud account that gives you like 300 credits for a year, and then do this AutoML stuff while it's in beta, because I think they're not charging you for it yet. All right. So let's go back to my other browser tab. Where is it? Come here. So this is the Google Cloud Platform. And you can see I'm in a trial right now. I've only been charged, this particular trial account is about 25 days or so old. And so far out of my 300, I've spent less than $2, and that's just for Google Cloud Storage. So to use Google AutoML, any files that you use to train your model, you need to upload to their cloud storage. But then they haven't charged me for object detection. There's 2 different categories here that are in beta. They also have an API. Remember, keep it simple. If their API can do what you need it to do without needing to train a model, I highly recommend it. Because training a model is not easy, and it's painstaking, and it's a lot of work, which you'll see here shortly. So I have 2 options, video classification and object tracking. Let's go in here. Object tracking is what I want to do because I have 2 cats, and I want to be able to detect those cats in my home videos. So the first thing you want to do when you're in here is you want to create a data set. So I'm just going to SMW 2019. Classification is if you're not trying to detect objects, but you're trying to detect concepts in the videos that you're uploading. So this is a basketball game. This is somebody riding a mountain bike at the Grand National Monument. But I don't care about classification right now. I care about object tracking. So then I go and I create my data set. At this point, I have the ability to import videos. So unfortunately, they don't give you the option to just upload through this interface. You have to create a couple CSV files. And notice that we need at least 100 bounding boxes per label, at least. So think of me sitting there drawing those boxes 100 times. So if you can crowdsource, you should. And there must be at least 3 videos. And that's just for basic object tracking. So we have these files here. You'll notice this is an example CSV. So in this CSV file is telling it, hey, I have a couple other CSV files that are pointing to what I want to use as my training data and what I want to use as my test data. If I don't want to determine that yet, I can just say unassigned. And if you open the CSV up, it's going to be the Google Cloud Storage link to where your video is, followed by about 10 commas. Unless you've used a service or you've used your own annotation tool to actually draw bounding boxes around stuff. Those commas are placeholders for where the bounding boxes and the label for that object exist. So I select my videos, and then at that point, it's going to import them, and we're going to go to one of my pre-existing data sets so you can see what that looks like. So here's my cat tracking 2 data set. And once you've imported videos, you'll see your videos here. And you can filter the videos based on the labels that you're trying to detect for your objects. But in my case, I have a number of videos here. Some of them are labeled based on the amount of time I had to do this, labeling. And I guess I labeled all of them. Okay, cool. But if you don't want to do all the annotations up front, they do provide this user interface that you can use that's kind of similar to the Microsoft tool I showed you earlier. So if I play this video, I don't want to tag that first frame, and maybe scroll through. Oh, there's my white cat, awesome. And why is this let me zoom out a little bit. So I could come in here and I draw this tight bounding box around my cat. And then I say, cool, that's Eero. And then I can come back and I can draw a bounding box around this cat, Ori. So you do this over and over and over again. And you want to get different angles. If they're not always going to be in the same environment, you want to capture different environments. If they're in the same frame together, you want to make sure to draw a bounding box around both of them. There's all these things that you need to do. Once you feel that, hey, I think I have a good training set now, you can then go to the Train tab. And you'll see that this particular data set I've trained twice. First time, not so good. Second time, still not so good. So you train, add more training data, train, until you get to that point where it's this model is usable and I can build an app around it. Remember I mentioned recall and precision before. So precise model is you want to make sure that you are getting everything but not getting the things you don't want. And then the recall is making sure that you don't miss anything. So tracking 1, the first time I trained it, it had an average precision of 0, but precision was 100%. It had 0% recall. And you'll notice that in this model, I have good precision, but my recall is still only about 50%. And you'll notice a difference here. The first model, I had 33 annotations in 4 videos. Google told me I needed at least 100. And then in this one, I had 83 annotations and 8 videos. So that was getting closer to 100, but it's still not enough because I have 2 labels, and I only have 83 annotations. So obviously, this training data set is insufficient. So I'm not going to get a highly accurate model the way that I need it to so that I can have an app where I can detect cat 1 and cat 2 and make sure that they're not detected as a bear. So once I have this, I can say I want to train a new model because I did more annotations 26 videos, 2 labels, I start training. Once I do that, there we go. It takes a while. It depends on how large your training set is and how many times it's got to switch between the training data and the validation data to determine, hey, am I accurate? And a way to think about it is it wants to get accurate up to here. It starts down here. And it trains and it validates, trains, validates, trains, validates, until you get to that point up there. So I'm getting closer because I have more annotations. Once that's done, you can come in here and you can look at the evaluation of what happened. And I'll just show you, it's a pretty large screen. I could see like how well it detected the white cat versus the brown cat, because my white cat is actually in more videos since that's the one I'm usually have on the leash that I'm walking around with the camera with. So it's pretty good on this white cat. Brown cat, I still need more training data. You can come in here and look. You can see like, hey, what is the score if I like set my, confidence level down to 20% or 25, and it will adjust these graphs and this information. And then finally, when you feel like, oh, I have a model that I think is pretty good, then you come in here and say test and use. And here you want to give it an input CSV of, hey, here are the videos I want you to parse through, my test set, and then also tell it where to put its results. Because it will actually spit out one JSON file per video so that you can then take that and use it in your apps. Or if you're good at REST API or know some Python, you can actually just automate this and not have to deal with the user interface at all. Right here was a recent prediction. And this particular, it's still in beta. This interface is somewhat wonky, at least on my computer. But I can play through a video. You'll notice that it didn't see anything, and it's at confidence 50%. If I slide this closer to 0, things will start to pop up. It's like, I think maybe the white cat was in 1.6 seconds to 5.2, but I'm only about 38% confident. So you can use this like in line within their interface to decide how well this model is working. And if it's not working well enough, you give it more training data, you train again. And you keep doing that until it's where it needs to be. I'll show you real quick what the JSON file looks like. So let's see. I think it's in here maybe. This is an example of a data set file. Export data. Video object tracking. Annotation, test, training. Here we go. I think that's it. Let me find the video or the JSON file real quick. It's the wrong one. What it looks like, I'm just going to show you something similar. But the concept is once we're in here, oh, what's going on here? How long has it been flickering? The whole time? Okay. All right. Yes. All right, just real quick. So we're going to have like JSON that gets spit back, and I'll kind of show you that's JSON right there for those of you that are unfamiliar. But what you'll see is you'll see your label, and you'll see the confidence, and then you'll see like where it saw that object, and then you'll get a bounding box of XY coordinates so that you can then take that JSON, ingest it into your app, and do whatever you want with it. Maybe it's a way to just, instead of scrubbing through the timeline, you could say, I want to scrub from my cat to my cat to my cat to my cat. But so yeah, so this is pretty cool. I highly recommend playing around with it now if you're cool creating training data sets or having somebody else do it for you. So yeah, if you want to contact me afterwards or pay attention to what I'm cooking up in the labs and playing around with, feel free to grab my card, hit my email address. My company's URL is right there. It's a pretty beautiful looking site. Some of our developers worked on it and I really like it. And then if you can spare me a couple minutes and go to that bit.ly link and fill out the feedback form, I would be very much appreciative. And I thank you all for your time this afternoon. Thank you.